Before starting the review of the practice quiz, let's go over the derivative rules for the trigonometric functions, sine, cosine, tangent, and then the reciprocals, cosecant, secant, and cotangent. That is, the definition of cosecant is 1 over sine. The definition of secant is 1 over cosine, and the definition of cotangent you can think of as the reciprocal of tangent. So the derivative for sine is cosine. The derivative for cosine, it'd be nice if it was sine, but it's actually minus sine. And then for tangent, I like to write this as secant squared. Now for the reciprocal functions, cosecant, secant, and cotangent, I'll start with, secant. The rule, I write it as secant, so you actually get the same function back, but you multiply by tangent. The rule for cosecant looks similar, where you start with the cosecant function, but it's negative. So you get negative cosecant, but then you don't multiply by tangent, you multiply by cotangent. And then the derivative rule for cotangent is a lot like the one for tangent. It's not positive, it'll be negative. And it's not the secant function, but it's the cosecant function squared. So here are the 6 derivative rules for the trigonometric functions. So what is the derivative of secant of 8x? Well, we have to use the chain rule here because we have a composition of 2 functions. But the rule for secant is secant tangent. And in place of the x's, we'll copy down the 8x. So the answer here is going to be, well, it's secant of what's composed into the function times tangent of what's composed into the function. But then by the chain rule, you have to multiply by the derivative of just the 8x, which is 8. Now down here for the derivative of a cosecant function, notice there's an extra negative here in front of this expression. So when you take the derivative of just cosecant, you get a negative. Along with this extra negative will become positive, and I'll just put this positive here for emphasis. It'll be positive cosecant cotangent. Again, we have this 8x that's inside composed, so we have to use the chain rule at the end. So it's positive cosecant of 8x times cotangent of 8x, and then by the chain rule, we multiply by 8. You don't have to write this positive. I just wrote that because there was a negative here. You get a second one from actually applying the derivative rule, and so they cancel. Okay, let's move on to the review for the quiz. Let's go over a couple of examples for this week's discussion quiz. The first question is multiple choice, meaning we'll put the capital letter corresponding to our answer in this box. We're asked to differentiate the function 7 times 8 to the x plus 9 secant of x. And I'll start by just going through term by term. So let's see, we have an exponential function multiplied by a constant. You can actually just start by writing down the constant, which is 7, and then you multiply by the derivative of whatever you get from 8 to the x. This is an exponential function, meaning you get the same function back, but you have to multiply by the natural log of the base, and that's the rule for that particular equation. Next, you're going to take the derivative of the secant function and multiply it by 9, so I'll put plus 9 times whatever the derivative of secant is. And I know that is secant tangent. And in fact, unsimplified, here's my answer. Hopefully that is one of the choices that is listed below, and in fact it is. It appears to be choice A, which is 7 times 8 to the x times the natural log of 8. Added to that is 9 secant tangent. This one's off by a negative. This one and this one, well, actually this one's missing the natural log of 8, and it's also negative. This one here has the incorrect derivative for secant, so A appears to be the correct answer, and that is it for this question. Question 2 is free response, so we have to show our work and not just the final answer. But this one says to differentiate the function f of x, which is x cubed times sine of x. Here we have 2 functions being multiplied together, a cubic function and a trig function. Therefore, we have to use the product rule. So this is f prime of x is equal to the derivative of the first, which is 3x squared, and then we just copy down sine of x. To this we add, all right, now we reverse this. We'll leave the first thing alone, but multiply by the derivative of the second, and the derivative of sine is cosine. And we do not have to simplify our answers, so this is the final answer to this problem. For part B, we have to find the derivative of the function h of x, and I see this is a composition of two functions. So it's the cotangent function with e to the x plus 1 in place of it. This means we have to use the chain rule. So let's make note of that. We're going to use the chain rule when applying this problem. So the derivative h prime of x is, okay, we start with the derivative of cotangent. That is negative cosecant squared of whatever's composed inside of this equation, which is e to the x plus 1. By the chain rule, we multiply by the derivative of the inside function. 1 goes to 0. I'm not going to write that. And the derivative of e to the x is e to the x. So this is the answer to the derivative of h of x.